Hey everybody, this is Alex Merced from alexmercedcoder.com, and you are watching me talk about Ruby. Okay, so the point of this video is a Ruby functions masterclass. So we're going to go into not just how to make functions, but we're going to talk about anonymous functions, bindings, procs, lambdas, all sorts of fun stuff. So let me open up my Ruby play file here. Boop. So first, let's just talk about functions in Ruby. So the simplest way to just define a function, okay, it's kind of very similar to Python. You use the keyword def, so you're defining a function. Now the cool thing about Ruby is you don't need parentheses. So if my argument, let's say hello world, doesn't take any arguments, then I can just do that. Okay, and then again I end it with end. So if I just say hello world, this is just going to be an implied well, let's start from scratch. What is a function? A function is just basically some code wrapped up to a namespace that we can call whenever we want. So if I say def hello world, okay, and I say puts hello world, okay, you should know what puts are. If not, you need to go watch my earlier Ruby videos. Okay, so now that I've defined this function, I can then call this function. And again, in Ruby, if the function takes no arguments, I don't need to give a parentheses. So I don't need to put a parentheses to invoke it. So I can just sit there and do this over and over again, and it'll run the function. Okay, which will print hello world to the console. So let's run the terminal. New terminal. Okay, and then I run ruby test.rb. Uninitialize constant hello world. Let me think about that. Am I running the right file? Test.rb. Puts hello world. Did I spell it differently? Hello world. Hello world. So I guess maybe it doesn't want me to put parentheses. Usually I don't. Interesting. Let's see here. Yep. Okay, that time it did want me to invoke with parentheses. Sometimes it does, sometimes it doesn't. That's weird. Okay. So in that case, it did. I think it's probably because I used capitals. So it's looking at a constant. So probably if I change this to H, the camel case, I think then we'll be okay. So let's try that out. Hello world. Yeah. Okay. So if you name it uppercase, it's going to think it's a constant, and if it thinks it's a constant, you're going to need to put the explicit parentheses. So that's something important to know. Okay, but that's how you define a function. You say def hello world. That means I'm defining a function called hello world. Now, like functions in other languages, I could define arguments that you can pass in there. So let's say we'll call this first arg. Okay, so one argument. So instead of putting something set like hello world, we'll just say it's going to put first arg. Okay, so then we'll just pass world cheese hello world Gouda hello world provolone. Okay, and you see I'm passing in an argument. So this is the argument, and then this argument fills in this is what goes inside this little bucket first arg. So then when I put first arg, it's going to put whatever I put in that bucket for that call of the function. So now if I do this, see it says cheese, Gouda. So first it prints out cheese, then it prints out Gouda, then it prints out provolone. Okay, and you can do as many arguments as you want. So I can be like first arg, second arg. So puts first arg plus second arg. Okay. And actually I haven't tried this out in Ruby yet, but in most languages I can do this. So let's say I don't want to actually put in a second argument because I'm too lazy to type. I could define a default argument here. So put space hello. Let's see if that works. And it does. Okay, so see, since I didn't pass in a second argument, see I only passed in one cheese, because I put this equal sign there, that treats it as a default argument. So if I don't specify second arg, it's going to assume it's hello. Okay, nice. Okay, so that's the basic idea of a function. And let's say I do this. I take the puts out. Okay, it's no longer going to print it to the screen, but it's going to automatically return it. So whatever like the last line of the function is, it's going to assume that's what I'm returning. So now I can do like puts. So now if I do it this way, I'm putting the return value of the function. So this function is going to return cheese hello. So I'm going to get the same result. Okay, but if I took out the puts, you'd see nothing. So let me just take out all these puts here. Because again, while the value is being returned, we're not seeing it because we never told it to actually show it on in the console. So see, it just looks like nothing happened. Here in the terminal, see, like I ran the command, then it just went right to the next line. Okay, so I could be explicit about my return and be like return first arg and second args, same deal. Okay, but again, the cool thing is that it'll automatically assume whatever the last line of the function is. If you don't specify a return value, whatever the value of the last line in the function is the return value. So this is just a standard function. Okay, so again, you can put as many arguments between def and end, or def as many commands to create your function. Okay, wonderful. Now the other fun thing you can do is that there's some things called anonymous functions. Okay, and they come in different flavors. Okay, first one is called a block. So let's talk about a block. Okay, so first let me define a function. Define my func, which all it's going to do is yield something, and it's going to pass the number 5 into whatever it yields, and you'll see what that does in a second. And so whenever you see the word yield in a function, what it means is that it's waiting for a block to be passed in. Okay, so if I were to run my func, what I can do is I can pass it, and again, if there's only one argument, you don't need parentheses. So since there's only one argument that I'm passing, which is going to be a block, I can just do that. A block's going to be in curly brackets, and the way the block is formed, okay, is I can pass in this for an argument. So this is like saying that's the argument, and then what the function is going to, what the block is going to do is puts x. Okay, so I'm basically passing this block of code to my func. And what it's going to do is going to say it's going to run this piece of code when it hits yield, and I'm passing in 5 into whatever block is passed in here. So this 5 becomes x, and it should put x. So let's just double check that that works that way. Okay, and it does. Okay, so again, what's happening is I'm passing in this sort of block into this function, and it's going to get run anytime and if I do yield multiple times, so if I do yield 4, yield 3, it's going to run that function and pass that argument in multiple times. So you can create functions that have multiple uses depending on what block you pass in. Okay, kind of like callback functions in JavaScript. Okay, so that is a block. Okay, so that's one way you can kind of do sort of an anonymous function. So I'll comment that out. Then there is a lambdas. Okay, what I can do is I can store a lambda in a function, so in a variable. So my lambda, okay, equals, and the syntax for lambdas, you're going to use the arrow, this arrow here, a thin arrow, or a skinny arrow as it may be called. That's where I can specify the parameters, and then a block for what it does. So we'll just say it returns, and you don't use the word, it's just going to return whatever the expression inside the curly brackets is, x plus 2. Okay? So then I could just use it by saying my lambda equals or no, actually puts the result of my lambda dot call. That's how you have to call the lambda, because it's like a property of an object that gets stored in a variable. Essentially like a prop. From my understanding, the way it works is like this proc object gets created that gets stored in my lambda, and then the function you pass in, which is this, gets called as part of the call method on that object. Okay, which is going to be the same way the proc that works next is going to do, just a slight difference. Okay, my lambda dot call, and we're going to pass in an argument 5, so it should give me back 7. Undefined local variable, my lambda. Oh, did I spell it wrong? My lambda. My lambda. Did you mean my lambda? I did mean my lambda, but isn't that what I spelled here? Let me think here. Undefined local variable or method. Well, maybe I don't use the call method for lambdas. Maybe I'm remembering it wrong. Nope. Let's see here. My lambda equals that call 5 my I spelled lambda. Lambda. Oh, I gotta read better. Okay. There we go. So, and it works. I was gonna be like, wait a second, I thought this works. Okay, so it works. So again, what's happening here is when I say my lambda dot call, it's gonna call this function that I defined in this syntax. And then 5 is the argument I'm passing into the function. So it's x plus 2, 5 plus 2, 7. That's what gets returned, and that gets what's puts out. So it's just one way, kind of like an arrow function in JavaScript. Except you can really only do like one expression here. Okay. Cool. So let's, like, if you needed like something a little bit more robust, then you could use a block. So let me go back up here to the blocks to find another block. So I can be like, my block equals, and then do something like this, like x do, and there's an end, and then it'll be like puts x. Okay. And then if I were to bring back my other func, my func, I can be like my func, and then pass in the block, my block. And let's try to see if that works. So again, what it'll do is it should be putting x, because again, here's the parameter, do this block. So for every x, do this block. Unexpected, do, and expecting end of input. Should be something like that. Maybe I'm supposed to put the x on the other side of that. Meh. Something like that. I'll come back to that. Okay, but the point is, there are blocks that you can define this way. Again, it's just basic curly brackets. There are lambdas, which you can define this way. Okay, and again, the difference is blocks you can use as yield function. Okay, so you can call the block from within. Lambdas, where you don't work with the yield function. You could pass a lambda into a function, but then you have to kind of pass it as an argument into its a named parameter. And it has one slight difference with this next thing called a proc. A proc. Okay, and a proc would work like this. So my proc. Okay, and my proc equals, and it would be proc.new. We're creating a new proc, and then you use curly brackets, and then you define the parameters this way, x and x plus 2. So essentially, this is functionally the same thing as this. There's a slight difference, okay, under the hood. But if I just do this, my proc.call, and I pass it in 5, it should end up giving me 7 again. Actually, I should probably put the results. So puts, so I get 7. Okay, now where we start seeing a difference is, so let me undefine this lambda here. Okay, puts my proc call. Okay, so let's say I define a function, right? Define my func. In my func, first I say put before lambda. Then I run the lambda. So my lambda dot call 5 puts after lambda. Then I run my proc dot call 5. Doesn't really matter what the argument is for this. Okay. And then I put puts after proc. Let's watch what happens. Okay, and what does it not like? Okay, and then we'll use my func. Okay. Undefined local variable. Lambda, no. I think it's because I use lowercase, so everything is local that way. So I'd have to. So I would need the 2 definitions here, so I'll just do that. There we go. So we have the local definitions of those parameters. Okay. And let's add a return, the keyword return. Okay, so notice what happened here. Because I used the keyword return, see the first time it went through all the puts. And that's without using the return keyword. So the implicit return didn't affect anything, allowed me to run through all the puts. So basically it did this put, then ran this code, then did this put, then ran this code. That's great. But now when I added the return keyword, when the lambda return x plus 2, the lambda gets its own execution context in the sense that it's like having a function inside of a function. So it's really the function inside the function that's returning a value. Now a proc doesn't get its own execution context. So when I return in the proc, it's the same thing as me returning in my func. So it stops there. This is really sort of the important difference between proc and lambda, otherwise they kind of do the same thing. So when my proc returns a value, it stops the context in which it was in. So the my func execution context ends because a value has been returned. It's as if my func returned x plus 2. Okay, so it's just a difference in sort of like how they are treated within. So like when I treated them separately outside as just standalone functions, there was no difference. But inside the context of another function, the proc and the lambda have an important difference. Again, lambda gets its own execution context. So when it returns a value, that execution context ends. This function is still going, so it keeps going. So that's why I went to after lambda. But my proc does not get its own execution context. So when it returns a value, it terminates this execution context of my func. So my func ends and never gets to after proc, which we see never got printed. Okay, so that's sort of the best way to kind of see the difference between a proc and a lambda. Otherwise, this is the same stuff. Outside of a function, this is pretty much the same thing. Okay, but depending on like what, having anonymous functions being passed into a function, depending whether you write it as a lambda or a proc, it can have, some implications on how the code executes. So that's kind of important. Okay, cool. So again, let's recap. We have blocks, which are just basically this syntax. Okay, passed as an argument to a function, and then it gets called within the function with a keyword yield. Then there's a lambda, which uses this function, which gets called this way. Okay, and I'm going to comment that out. Then there are procs, which use this syntax to be defined. But again, procs and lambdas are both anonymous functions to an extent, but again, lambdas get their own execution context, procs don't, okay, within the context of another function. The last thing I want to teach you guys is about binding. So this is basically making, you can make variables that are in a function, which usually have a local access, local scope, so you can't access them out of the function. So for example, if I said this, def my func, and in my func we create a variable called cheese that equals Gouda. Okay, that equals Gouda. I'll just make it the symbol because I'm too lazy to type quotation marks. Def my func. Okay. Now if I do this and then I were to go puts cheese, I am going to get an error because cheese doesn't exist outside of my func. It's a local variable to the function my func. So if I run the code, okay, see undefined local variable method cheese, it doesn't exist. Now if I use the keyword binding, what it does, it kind of takes a snapshot of the function in that moment and makes it where I can now access those variables outside. So now I can do puts my func dot eval, okay. I'm trying to remember if it's, I think it's this. It's either parentheses or it's square brackets. We'll find out in a second. And then I can call upon the cheese variable that's referred to inside that function. So it kind of creates access. So let's just remember if it's parentheses or square brackets. Yep, parentheses. So basically what you're doing is you're saying, hey, go grab me the cheese variable that exists within this local context within the myfunc function. Okay? And that gives you access to those local variables inside. So I may return something else. So this may return another value. Returns the number 5. The function returns 5. Actually, I'll put that after the binding. Okay, so if I puts myfunc.eval, but then I go puts myfunc, so you can see the difference. Okay, first it's going to console log Gouda, because I'm grabbing it from within that execution context, versus here where I'm just putting the return value. So I go yay, and let's see here, private method eval called for 5. What happened there? Cheese. Why is it called for 5? I think it's, let's see what happens if I move the word binding around. Okay. Let's see here. Well, let's just define multiple variables so you can see that. You can define all sorts of data in here. Hello equals provolone. Getting some trouble with the return value. I think the binding may change how that works. So let's see here. Puts myfunc.eval provolone. And this is kind of an interesting thing you can do. You can probably use it to make a function return several values. Okay, no implicit conversion. Oh, I put the symbol there. My bad. You have to pass a string as an argument. Provolone. What? The provolone. Oh no, it's because it's called hello. Hello is what it's called. Hello. There you go, Gouda provolone. Okay, so see, I can access all those variables because I use this keyword binding. Now, if I took this out, that's not going to work. Okay, see, I get an error. So, binding allows you to access local variables from within a function outside through this method, which I can't imagine a lot of uses for. And like if I need to return multiple values outside of a function, I'd probably use an array or a hash. Again, a hash is more similar to like a JavaScript object if you're new to Ruby. But it's a thing you can do. Okay, again, you have lambdas, procs, or your anonymous functions, and blocks. And again, just a normal run-of-the-mill function is just done through def name of function, some code, and then end. Okay, that's basically it. That's the world of functions in Ruby. Of course, there's always more you can do, but this gives you sort of a nice cornucopia, nice introduction of some of the really interesting function features that are in Ruby, because some of these things, well, like lambdas do exist in Python. You have arrow functions in JavaScript. Arrow functions are kind of unique in the way they particularly work in JavaScript. But yeah, it's a very interesting how you have kind of multiple versions, the blocks, the procs, and the lambda as far as anonymous functions go. While usually you have like one flavor of anonymous function in most languages. You know, it's like you have functions that are named, and you have anonymous functions that you can just kind of pass in and make on the fly. Versus here, where you have three ways to do anonymous functions: blocks, lambdas, and procs. And then this binding thing is kind of an interesting feature. I don't think I've seen that in other languages, or at least not yet, but that's pretty cool. So I'll leave it there. Hopefully this gives you a better idea of sort of the scope of what the cool things you can do with functions inside of Ruby. My name is Alex Merced from alexmercedcoder.com. Have a great day and enjoy.